In this video, we are about to start the chapter 6, which is about normalization of database tables. As we have now, as you have some idea about the different types of keys, and those are necessary in the database systems or database development. Now, using those basic concepts or key concepts, we are going to learn about a new concept called normalization. From an information management point of view, possibly the most vexing and destructive problems are created through uncontrolled data redundancies. Such redundancies produce, if you may remember, I already told you about the update and delete anomalies. So, what are those anomalies? Again, some sort of modifications or errors that may happen while you try to delete some data from one or more than one table at a certain point of time, or let's say you want to do some types of modification or updation in the table, and that may lead to some sort of data integrity problems later, all total in the database. The loss of data integrity can destroy the usefulness of the data within the databases. The table structures are poor whenever they promote uncontrolled data redundancy. So, normalization is a concept that provides an organized way of determining a table's structural status. So, here in this chapter, we will cover the basics of normalization and its role in database designing. Then there are various normal forms that we have to learn. First NF, second normal, second NF, third NF, BCNF, and fourth NF. And we will also discuss about how the normal forms can be transformed or updated to lower normal form or higher normal forms. And then we will see how to apply the normalization rules to evaluate and correct table structures. Then denormalization, and then we will see how the data modeling checklist evaluates that entity relationship diagram to meet its a set of minimum requirements at least. Okay, so let's see what are database tables and normalization. So let's speak about normalization first. Normalization is the process of assigning attributes that are the characteristics to the entities. Properly executed, normalization process eliminates uncontrolled data redundancies, thus eliminating the data anomalies and the data integrity problems that are produced by such redundancies. Normalization doesn't eliminate data redundancy or data duplication. Instead, it produces the carefully controlled redundancy that lets us properly link database tables. Okay, so now we will see what is the structural point of view of a normal form. So to defining that, we should consider the higher normal form, okay, are better than the lower normal form. It is always advantageous um, to make sure that your current table in which you are currently working right now, so that satisfies the most higher normal forms. So it's always better to see what are the higher normal forms of the given database, and properly at least up to third normal form, we should at least reach up to third normal form. So properly designed third normal form structures meet always the requirement of fourth NF. So first, whenever you have a database or set of tables, first make sure whether it's in first normal form. If it's in first normal form, go to second normal form. If again the table can also be divided, then you can move on to third normal form. So at least to ensure data integrity, you should make sure that your table satisfy the third normal form. How, we will discuss about that. Then, like normalization, denormalization is a process that produces the lower normal form, and it basically increases the performance and greater data redundancy. Then the need for normalization, it's used while designing a new database structure. So it helps for analyzing the relationship among the attributes within the entity. Then the structure is also improved by this, and the data structure and data designing is also improved as well. So let's see one diagram. Here, see, this is a sample report layout. There are some records, and if you see in one block, there are multiple values. So, in one record, you see multiple employee names, multiple employee number, and one project name is assigned to multiple employees, job class, employee numbers. So, here in this table 6.1, it organizes the data for each project into a summary format. So, as per you, just take a look at it and just think that whether this is an ideal database. So, if someone will ask that, what is the total number of hours built for a project named Starflight? So, what will be your answer? So, which one hours build you will answer about that? Among these 1 to 3, yeah, 7 hours build. So, what is your answer and how would you answer that? So, is it satisfying the data integrity of this database or report layout? So, if we try to reorganize the figure 6.1 again around the projects, just as the report was organized, then with each project having a single row to represent the data associated with that project, and is and can you say this is normalized? So normalization means what? When you have a, database or table which satisfy the data integrity. So does it improve? Does it show basic data integrity or satisfy basic data integrity format? So if you see the project name Evergreen, it is having multiple value in one row for EMP number, multiple values of employee name in the EMP name column in the same record, same row. So is it ideal design? No, actually it's not. Then what are we supposed to do? So here comes the process of normalization. The objective or the motive is to ensure that each table conforms to the concept of well-formed relationship. So what are the properties that we should adhere to? So these are: each table represents single subject. Okay, if you are writing something or having the data about students, so the table should have student data only. In the student data, you cannot incorporate the employee data or the administrative data. So each row and each column intersection can contain only one value. So if you see in the structure, each row, each column, let's take this EMP name column. So is it associated with single value? So no. Okay, so every column intersection, row and column intersection must be having only one value. And no data item will be unnecessarily stored in more than one table. So no data duplication. There is one concept, I will get into that later, that is non-prime attribute in a table should be dependent on the primary key. That is another one concept. You will understand it in a better way with an example. I will get into that later. Then there should be finally no insertion, update and deletion anomalies. So if you are inserting a data into one table which is connected to another table, so it should be done in a certain way that the other table which is dependent on the first table, it shouldn't be impacted. The same thing goes on for deletion and update as well. Always you have to make sure is there enough data integrity in the table database or not. Okay, and we have to make sure that at least our tables are in third normal form. After that you can move over to BCNF or fourth NF, but minimal you need to have the third normal form. uh, okay, so let's go to the normal forms now. So here see, we are going to just emphasize on these 5 normal forms. First normal form, second normal form, third normal form, BCNF, that is Boyce Court normal form, and fourth normal form. And see it's easier to remember the features of each normal form on the basis of which you will divide your relations or the data tables. So for that, this table is most beneficial because each of the normal form has been given with their individual characteristics. Okay, now after this, to understand normalization or to start with normalization, you should know some other basic functionalities or concepts called functional dependence and some examples of it, and fully functional dependence also. So these are the concepts that need to be learned first.